Example number 5. It's pretty straightforward. It says, what's the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18. So here's a compound inequality. This could be used in the real world. Both inequalities represent some sort of value, some sort of tolerance in a manufacturing process, some sort of business model where you have two different parameters that have an inequality based on the tolerances or the range that you want the values to be. And so you want to see what you would do. Now let me give you an example. The numbers might not work exactly, but maybe Mr. Adams is driving 3 buses, but I could borrow 5 buses. So that means for this field trip I'm planning, I could use 3 to 5 buses. But the number of buses depends on the kids that I'm taking. One bus is a smaller bus and only holds 40 students, and the remaining buses hold 60 students. So then I need the parameters. In order for me to go on the field trip, I need at least 100 students. But I can't have more than the grand total of all the buses. So in that scenario, you can see where I have one inequality representing how many buses I need, and another inequality representing how many students I need, and you can see how the two have to overlap, and I have to solve both of them simultaneously. Here's an example of that. So now what I could do is I could solve each one independently. So I could say 7 less than 2x plus 1 minus 1 from both sides. And I get 6 is less than 2x, divide by 2, divide by 2. 3 is less than x, or x is greater than 3. Does that make sense?
Yeah. See.
All right, cool. So now let's do the other one. So now for the other one, I've got 3x is less than or equal to 18. Why'd I flip it?
Why'd you flip them?
I can't see them. Where do you flip?
Hold on, let me finish where I'm at. You mean this here? Why did I flip that?
You just rewrote it. Jeez.
I just rewrote. Let's do it this way though. All right. You ready? Let's graph these. Now watch how I graph these. Got my number line. I got two numbers that I'm dealing with, 3 and 6. Let's start with this one first. 3 is less than a number. Think of a number that 3 is less than. 4. Are we including 3?
No.
No, we're not. And 4 is over here, so this is the direction I want to head. Right?
Yeah.
Because 4, which is on the right-hand side of 3, would make the inequality true. But now I'm dealing with x. Do we include 6 in the second inequality?
Yes.
All right. Now think of a number that makes that statement true. X, a number, is less than or equal to 6. What number is less than or equal to 6?
6.
4 or 6 or 3.
Or 5.
Well, technically, negative 20 would be a number that would satisfy it, but we want something that will satisfy both conditions. 4 would, but anywhere from 3 up to 6. Now, how do I? Don't get ahead of me. This I graphed it on purpose because it's very easy to see. But what can my solution be? Well, 3x is somewhere in here, right?
Yeah.
So x is less than 6, but greater than 3. But we would write it differently. We would say 3 is less than x, which is true. And x is less than or equal to 6.
Oh, that's pretty scalding.
Huh?
Nothing.
You got 100% on your arithmetic. Is that what you said?
No, he said this is preschool kills it. Oh,
I didn't say that.
But you have 100 on your arithmetic?
Yes.
What about algebra 1?
he's working on it.
I finished Khan Academy.
Now you're just lying.
I did calculus.
Calculus, pre-calc, all of it.
Preschool.
Let's do one more combo. By the way, these are called combined or compound inequalities.